Hi, today we are going to continue lesson 12.3, day 2 on geometric series, which means to add the geometric sequence together. And we are going to start with example 1. Yesterday we were given A, N, and R, and we just straight plug in how to do the problem. So today we're just going to continue, and let's take a look at the first example. So notice that we have A, N, and R that we need to identify before we can find the sum. So the first initial value is 4. We already know that. The ratio is negative 12 divided by 4, which is negative 3. However, you see the 3 dots in between here? We don't know how many terms that will be until we get to 2916. So therefore, N is actually unknown at this time. So we must do one more step to obtain N. And we call that the nth term, or f of n, is given by A times R to the n minus 1. So the nth term is given by this, and we are actually given A and R. So we can actually find the nth term. That will be 4 times negative 3 to the n minus 1. We do not know what term that will be, but we're going to set it equal to 2916 because we want to find out what n equals, like how many terms it will take us to get to 2916. And so we're setting it equal to, and we're going to try to solve for n. The first thing we should do is divide both sides by 4, and that will leave us 729 equals negative 3 to the n minus 1. And we're going to rewrite the 729 as a negative 3 to the 6th power. So if you want to verify in your calculator, you can take negative 3 raised to the 6th power and see if that will give us 729. And we're just going to bring down the right-hand side. And since the base are equal, we got exponents are equal. So 6 is equal to n minus 1. Adding 1 to both sides, and will yield the answer for n equals 7. So now we have identified n, which is 7. We can proceed to find out the sum. So we're going to use the sum formula. S of n equals A, which is the initial value, that would be 4, times 1 minus the ratio, which is negative 3, and then to the nth power. Now we know n, which is 7, so we're going to substitute that, and it's 1 minus the ratio again on the bottom. And we need to do step-by-step work here. So we're going to simplify negative 3 to the 7th power first. So we're going to copy everything else. 1 minus, and then this is negative 2187. Go ahead and verify with your calculator if you need to. Divided by negative is now plus, so 1 plus 3 on the bottom. And we still have that 4 over, and then these two will combine to 2188 on top, and then 4 on the bottom. And the 4's will cancel out nicely. That will leave us the answer of 2188. And that should be the sum of adding this sequence up. And that is how we solve this problem. So basically, we're going to repeat the same steps that we just did. So if you want to pause the video and try this next problem before we go on, you may go ahead and do so. So let's go ahead and solve this. The first term is A, which is 1/4. And then we got N and then R. Again, because of the 3 dots, we do not know what N equals, so we need to solve that first. And we know that the ratio is the second term, which is 1/8, divided by the first term of 1/4. That'll be 1/8 times the reciprocal, which is 4, which we know is 1/2. So we know at least the ratio is 1/2. And we're going to find f of n using the same formula, initial value, which is 1/4, times the ratio to the n minus 1, and that will be our nth term formula. And we're going to substitute 1 over 512 because we do not know how many terms it will take us there. So substituting, and first thing I'm going to do is multiply the 4 so we can get rid of that 1/4, and that will bring it down to 1 over 4 cross cancel, will be 128 on the bottom, and that will be 1/2 to the n minus 1 still on the right hand side. And we're going to rewrite the 128 as 2 to the 7, and then distributing that power, it'll be 1 over 2 to the n minus 1. So now we got top equals top, base equal to base, and then exponents must equal. So n minus 1 equals 7, add 1 to both sides, and we have n equals 8. And now we figure out that n is equal to 8. We can proceed to find s of 8, which is initial value. That is actually 1/4 times the sum of 1 minus r, so that would be 1 minus 1/2 over, and then raised to the 8th power over 1 minus 1/2. And that's the ratio again. And so we're going to take 1/2 raised to the 8th power. So and then we're going to combine it with a 1. And dividing by the bottom, so we're going to use the calculator to help us out, dividing by 0.5 on the bottom. That will give us 1.99 about, and then dividing by 4, it will be approximately 0.498 or approximately 0.5. And that will be the sum of this sequence right here. Next, we're going to take a look at this problem right here. And that will be, again, this is a triad problem, so make sure you pause and try it before you go on. The first term is a equals negative 2.5. The ratio is negative 10 over negative 5, or 5 over, and you either way you're going to get a 2. And then we do not know n, so we need to solve for that. So f of n is equal to initial value, negative 2.5, times the ratio of 2 to the n minus 1. And we're going to let it equal to the last term, which is negative 160. Dividing by negative 2.5 on both sides will give us 64. And that will be 2 to the n minus 1. And we can rewrite that as 2 to the 6th. And we got the exponents equal. So 6 equals n minus 1. So n will equal to 7. And we just found that out. So we're going to look for s of 7, which is going to be initial value, negative 2.5 times 1 minus 2 to the 7 over 1 minus 2. And putting everything together in the calculator and use your step-by-step list to show work, we will have negative 317.5 as an answer. And that will be the sum for the series. And so, moving on to this problem, we have a is equal to 1/2, r is equal to negative 1/4 over 1/2. That will be negative 1/4 times 2. That will be negative 1/2. And n, again, we do not know, so we're going to look for f of n, which is initial value of 1/2 times r, which is negative 1/2 to the n minus 1. And then set it equal to the last term of negative 1 over 256. And times 2 to get rid of that 1/2, and will give us negative 1 over 128 is equal to negative 1/2 to the n minus 1. I'm going to rewrite the left side and the right side, bring it down, and we got powers equal, n minus 1 equal to 7, so therefore n equals 8. So now we can find s of 8, which is 1/2 times 1 minus negative 1/2 to the 8 over 1 minus negative 1/2. And solving everything, putting in a calculator, to help you, or showing your work step by step, you should have an answer of 85 over 256, or you can convert it into a decimal. Next, we're going to move into example 2, which is writing the infinite geometric series from the given problem. So a geometric series with 7 terms that begin with 1000 and successively decreases by 20%. So we must understand that we are starting with the term 1000, and so A is actually equal to 1000. And we know that the ratio is actually, if something is decreasing by 20%, that means it's only coming back at 80%. So the ratio is actually 0.8. And then we have n is equal to 7 because that is the given number of terms. So the next number that was going to be on the list is 800. So we're adding that and then adding 80%. So it's 80% of the previous number, 0.8. That will be 640. The next number will be 512 plus 409.6 plus 322.68 and finally plus 262.144. That will be the 7 numbers. So we're going to find S of 7 using the formula that we have learned. And that will be 1 minus, the ratio is 0.8 to the 7th power because we're looking for 7. 1 minus 0.8. Again, using your calculator to help you, you should have a total of 3951.424 as the sum of that list of numbers. And that's the end of the problem. The try it is going to be for you to try, so make sure you pause before you continue. And this is going to be n equals 9 because we're given 9 terms. We're starting with A is equal to -2, and the common ratio is actually given as well. So we just straight plug in S of 9 equals initial value, which is -2, times 1 minus the ratio is -4 to the 9 power over 1 minus a minus 4. And simplifying everything, you should have this one you should be able to show step by step. That will be -2 times 1 minus a -2, 62144 over 1 plus 4. And that will be -2 times 262145 over 5. And these two should be able to reduce inside to 52429. Multiplying by -2 will give you a total of -104,858 as an answer. Make sure you use your calculator to verify that that is the answer. And let's move on to the discussion question. How do you find n for a geometric series when only first few terms and the last terms are given? So that is just like the examples that we have done today. In the example 1, there was a few examples. So first, we need to use A, R, and A's of n to find n. So we know how many terms. And then use n, S of n to find the formula using the sum formula once we figure out n to find the sum. That's the discussion question. And that is the end of the lesson. So I hope you guys learned everything okay. You need to go back to the video if you are not clear about any of the problems. And don't forget your homework today is book set, HRW, and then copy the notes for day 3 and also Alex. And have a great day.